In this video, we'll be taking up the homework on composite functions. So the first question is pretty straightforward. They ask us to find the algebraic model of the composite function, so f of g of x and g of x. Not really much to say there. And then they ask us to evaluate f of 1 and g of f of 3. So these are very similar to something you would experience in grade 11. For question 2, they gave us two functions, n of t, which is the number of items made as a function of time in weeks, and then they gave us p of n, which is the profit in thousands of dollars as a function of n, which is number of items made. Now, if you nest n of t inside p of n, you get p of t, which is profit in thousands of dollars as a function of time in weeks, which is what 2a wants you to do. So you want to nest n of t inside p of n. For b, it's pretty straightforward. Just let p of t equal 180. Be careful, don't let it equal 180,000 because p of t is measured in thousands of dollars. For question 3a, you're just finding the inverse of f and inverse of g. Not much to say. I didn't show much work for inverse of g because I know the inverse of adding by 3 is subtracting by 3. So for 3b, there were 4 parts, and there really wasn't much to say about the 4 parts in terms of the algebraic work, but there is a very interesting relationship because for part 1, the answer is the same as part 4, and part 2 and part 3 are also the same. So I'm going to try to explain to you why part 2 and part 3, the answers are the same. So why is it that the inverse of g circle inverse of f of x is the same as f circle g and the inverse of that? I just realized I forgot my x over here. Let me just write that. So what I'm going to do is I'm going to, oops, I forgot inverse. Okay, let's try again. I'm going to prove that inverse g circle inverse f is inverse of f circle g. Because if I can prove that these two are inverses, then it makes sense that they are the same. Because if these two are inverses, when I take the inverse of f circle of g, of course, they're the same. Okay, so my goal is to prove that these two are inverses. Once I've successfully proven that these two are inverses, it makes sense that when I take the inverse of this function, I will get this function because I've proven that these two are inverses. So what I did was I went back to what I know about inverses. If the two functions are inverses, when I nest them together, I will get x. So I want to prove that if I nest this function into this function, or the other way around, I will get x. So I nested f circle g into this function, inverse g circle inverse f. So I use this notation over here instead of circle notation, just to keep it a little more straightforward. So when I nest it, okay, I'm forgetting a bracket here because this bracket's for this bracket. This is for this, so I need one more. Okay, so hopefully remember inverse of f, or inverse of f and f, of course, they're inverses. So when I have a composite, when I have a composition of two functions which are inverses, all I'm left with is the input value. So since these two functions are inverses, I know this seems a little weird, but all that's left is inverse g of x, which means that I can use the same logic as I did. Inverse g of x is equal to x. So all of this is equal to x, which proves that these two functions are inverses. So that's why the inverse of f circle g would be equal to inverse g circle inverse f of x. This is worthwhile spending some time because it's a very interesting relationship, but you really have to remember that when you have a composition of two functions which are inverses, then it's equal to x. That's critical to understanding this relationship. Number 4 is actually really straightforward. There's not much to say about that one. But I will say students get confused in the trigonometry unit. There's a huge difference between squaring a ratio and squaring the angle. So this highlights that fact. Okay, so next lesson will be modeling combining functions.